For more than 20 centuries, mathematicians, artists, and engineers have studied and admired these extraordinary structures. Skillfully crafted without the aid of blueprints or computers, every hexagonal cell in this section of Honeycomb is a masterpiece. Defined by 6 identical walls that connect at 120-degree angles, this chamber is ½ an inch deep, with a pyramid-shaped base that aligns perfectly with adjacent cells in the comb. Tilted upward at 13-degree angles, these cells are constructed to store honey, pollen, and new generations of bees. They have been called the pinnacles of biological architecture, designed to maximize storage area and stability with the minimum amount of building materials, specifically thin flakes of wax secreted from glands in the bee's abdomen. This precious substance is chewed, softened, and molded into rows of interlocking units that are bonded tightly without gaps or wasted space. No other geometrical shape, including pentagons, circles, or squares, can match a hexagon's combination of efficiency and strength. And every worker bee, everywhere in the world, knows instinctively how to build them. It's as if the hexagon is part of the bee's DNA. But the brilliance of a hive's construction doesn't end with thousands of perfect 6-walled containers. For recent studies have demonstrated that some of the most fascinating displays of honeybee engineering are revealed in a small quantity of what are, at first glance, imperfect cells. Ongoing research is being conducted and evaluated by scientists in the United States, Europe, and Asia. And with open frame hives and customized computer software, they have cast new light on the genius of the hive building process. In one study, honeybees simultaneously manufactured 5 teardrop-shaped pieces of comb. As these tongues grew larger by the hour, the bees were faced with a formidable challenge. How would they efficiently merge 5 independent sections, each expanding at a different rate and angle, into a flat, unified wall of comb that would fill the entire frame? Answers were discovered in the unconventional shapes of these highlighted cells, each embedded into a seam where 2 sections of honeycomb were aligned and joined during the hive's assembly. The magenta cells all have 5 sides, while the green cells have 7, and the deep purple 4. They are small islands in an ocean of hexagons and represent about 4% of the total cells in the comb. In 2021, a team of researchers from Auburn and Cornell universities made a series of observations that captured the attention of scientists throughout the world. Equipped with automated image analysis, they scanned dozens of large combs to measure the size, shape, and orientation of more than 19,000 individual cells. Scattered among rows of textbook hexagons, these irregular structures are not accidents or mistakes. Instead, each non-conforming cell was manufactured for a vital purpose. It now appears that honeybees can intentionally alter the shape and angle of specific cells in order to successfully merge and extend portions of comb through uneven spaces where hexagons won't fit. But that's not the only way cell positioning and size are adapted to meet the vital needs of the hive's inhabitants. With the exception of a single queen, colonies are populated by 2 types of bees, workers and drones. The drones are 30% larger. In this section of comb, we see how these size differences are managed during the construction of the hive's incubation cells. First, the workers erect rows of identical cells to shelter and nurture their smaller larvae. Then, they switch gears to build a cluster of nursery chambers for future drones. These cells are all enlarged by about 30%. To make a smooth transition, the bees not only create a few strategic irregular cells, they also construct 2 or 3 rows of slightly larger hexagons that each measure about 6 millimeters across. These intermediate cells, with their gradual increase in diameter, ensure that all available space and materials are optimized. In the process, the bees exhibit uncanny foresight by anticipating future needs of the entire colony before the queen lays a single egg. The engineering skills of a honeybee are truly remarkable. And as our understanding of the comb's iconic design continues to grow, so too will our sense of wonder for these insect architects and their ability to make cognitive decisions quickly and accurately at every stage of construction. There is now intriguing evidence that honeybees can anticipate logistical challenges and problems before they occur, and then solve them individually and collectively in ways that demonstrate creative engineering. Such aptitude, once deemed unimaginable in creatures with brains no larger than a sesame seed, now points clearly to design, purpose, and a master engineer who created all of life on Earth to reflect the eternal truth of His presence and power.